Hello! In the last devlog, we discussed the state machine as the foundation for this combat game. For this episode, it's going to be a quick and simple one. I want to discuss the interaction system. I feel like I want to set this system up early because it makes sense as an in-between step toward implementing the item weapon system. After all, it makes sense that to be able to wield a weapon, you first have to pick it up. And to pick it up is an interaction. So, while picking up a weapon is a good use case for an interaction system, I want to be clear that this system can work with anything. When there's an item to pick up nearby, then the system will communicate with it and start the process of adding the item to your inventory. But if instead you're standing in front of a door or an NPC that can be spoken to, then the same system will tell that door to open or start a dialogue with that NPC. So the goal here is simple. I want to be able to see when there's an item nearby that I can pick up. And then by performing the correct action, I want to be able to pick up this item, all without the character class knowing anything about the object it's interacting with. The heart of this decoupling is the interactable interface. Interfaces are like contracts. If an actor signs this contract, it promises to implement certain functions. Our interface defines a few key methods. Interact, what actually happens when you press the button. Show, hide, interaction prompt, which manages the UI visibility. And get, interact, action text, telling the player what they're about to do. I'm taking a lot of inspiration from the user experience of Zelda Breath of the Wild here. To actually find these objects, I created the interaction component. This is an actor component I can slap onto the player or an NPC. It owns a capsule component that acts as a trigger volume. Instead of doing a trace every frame, I'm using overlap events. Every time something enters or leaves our trigger volume, we scan all overlapping actors. We filter for actors that actually implement our interactable interface. And we find multiple, we calculate the square distance to find the closest one. When the target changes, we tell the old actor to hide its prompt and then tell the new one to show theirs. This ensures that the UI is always snappy and never gets stuck on when you walk away from an item. Finally, we have the interact function. It just calls execute interact on the target actor. By passing the player's state, the interactable object knows who's interacting with it. This is great for inventory items that need to know which player to add themselves to. So here we have the ItemPickup blueprint that I created to pick up items in this game. You can see here that it implements the interactable interface. When the interact method is called on it, it'll get the inventory component from the pawn of the player state that interacted with it. And then it will attempt to add itself to that inventory. This is the particular implementation of this method that I have chosen for this class. The other important thing here are the implementations of show interaction prompt and hide interaction prompt. The ItemPickup class has an ItemPickup prompt widget that has an item name set on it at begin play. The widget itself is just this item name on a black background. When this object is collided with by the interaction collider on the player, show interaction prompt is called on the ItemPickup object. And when overlap with this collider ends, then hide interaction prompt is called. This simply sets the visibility of the pickup prompt widget on and off. This class doesn't need to implement anything else in order to work as an interactable object. This system is completely actor-agnostic. I can create 100 different interactable objects and I never have to touch the player's code again. I know this is a simple implementation, but that's why I like it. If you have any thoughts on this system or improvements or better ones out there, let me know in the comments. Cheers!